All right, students. Hello, welcome. I know I'm talking in the middle of class and trying to get this thing to you. And Kiana is talking way too loud. But anyways, I'm going to keep going. So welcome to Unit 5 Notes. This is a comprehensive review of everything you need to know. Let's go ahead and get going. All right, we're talking about chemical bonds. So first you need to know what a compound is. A compound is two or more chemically bonded atoms that make up one new substance. So if you remember, if we have two atoms, we put them together, we make this thing called a compound. And by putting them together, they make a new substance. So think about like hydrogen. There's hydrogen gas, or there's oxygen gas. And when those two things come together, they make a new compound, H2O, such as water. So here's an example of a compound, NH3. It's written in this format to tell you that we have one N atom and three H atoms, and they are combined in a format that kind of looks like this. So why do atoms form bonds? Why do they make compounds? Well, there's kind of two things here. There's the rule of zero charge and the octet rule. These are two reasons that atoms want to form bonds. So the rule of zero charge means that atoms of opposite charge will come together in a ratio that will equal their total combined charge to be zero. The octet rule, on the other hand, are where all atoms form bonds to try to fill their outer valence shell. This is usually 8 electrons, or 2 if you're from the first period. So every atom wants 8 electrons. They want to fill that valence shell. Or if they're hydrogen or helium, or from the first period of the periodic table, they can only fit 2 on that first ring, so they only want 2. The octet rule is probably the most important rule. Everything follows this rule, where the rule of zero charge is only really followed by ionic bonds. So let's talk about that. So valence electrons first. So if you don't know what a valence electron is, valence electrons are electrons on the outermost energy level of an atom's Bohr model. They're the only electrons involved in a chemical bond, and they are responsible for an atom's chemical properties. So if you remember drawing a valence or a Bohr model, here's the Bohr model for silicon. You usually use the periodic table to figure out how many rings it has and how many electrons go in each ring. Now the ones we really care about are these outside electrons right here. These are the ones that are called valence electrons, and they're the ones that are involved in bonding, and why atoms bond. So here, the chemical symbol right here, Si, would be used, and then we would draw dots around it. This is known as a Lewis dot structure, and Lewis dot structures are really just this, the symbol here, to show just the valence electrons of an atom. So let's talk about ionic compounds. This is one type of compound where atoms come together in a certain way. So before we actually talk about that, you might want to think about this. How can you quickly determine the number of valence electrons an element has? Well, if you look on the periodic table, elements in group 1 all have 1 valence electron. In group 2, they all have 2 valence electrons. We're going to skip over the transition metals and go to group 13, or this is the main group 3, but group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8, except for, remember, helium. Helium can only fit 2 in its first row, so there's kind of one exception there. But you need to know that these are where the valence electrons are for each atom. So this is kind of what it looks like, right? Every time a new ring is formed, the valence electron starts over. So that's why group 1 has 1, group 2 has 2, because every time we start a new row or a new period on the periodic table, a new ring forms and they start new valence electrons. So let's go back to ionic bonds. Before we talk about ionic bonds, we need to know what an ion is. An ion is atoms that have a charge. And the reasons they have a charge is because their protons and electrons are not in balance. Normally, protons and electrons come together in the same ratio in order to cancel out and form a charge, but atoms can form ions when they have an imbalance of these protons and electrons. Now, just so you know, you can't change the protons. The protons define the atom and tell you what the atom is. So even though the protons add positive charge to an atom, you can't change them to change the charge. Electrons are really what's in charge. So there are two types of ions. There's cations that are positively charged atoms. That's what we call atoms that have a positive charge. We call them cations. Anions, on the other hand, are negatively charged atoms. Now, in order to make a cation or a positively charged atom, you can't add protons. I just said that you can't change the number of protons. So the way we do that is we have to take away electrons. Now think about that. Electrons are negatively charged, so if we take away electrons, then that means we're taking away negative charge, leaving positive charge. So that's why positively charged atoms are those created when we take away electrons. Now, negatively charged atoms are just the opposite. They're where we add electrons, so where more electrons are added to the mix. So if we add more electrons, then it will become an anion, or negatively charged. So why do atoms form ions? Well, it has to deal with the octet rule. So let's talk about an ionic compound. So ionic compounds are compounds formed between a metal, and metals are the things that form cations. If you look over on the left side of the periodic table, groups 1, 2, and 3 have 1, 2, and 3 valence electrons. Now they want to get rid of their electrons and become positively charged. The nonmetal atoms, groups 15, 16, and 17, have lots of electrons, and they want more. They're so close to 8, so they'll get 8, and they'll become negatively charged. So they do that by transferring their electrons. So ionic compounds are compounds formed between positive and negative, or metals and nonmetal atoms, that transfer their electrons in order to gain their full valence shell. Now, once they transfer their electrons, they become charged, and then they stick to each other because they have opposite charge, and they'll stick to each other in order to neutralize that charge. So ionic compounds not only follow the octet rule, they follow the rule of zero charge. So here's an example. Here's sodium and chlorine. Sodium has 1 valence electron. I know that from the periodic table. And chlorine has 7 valence electrons. I know that from the periodic table. Now, what's going to happen in this scenario? Sodium is going to transfer its valence electron to chlorine, kind of like this. So what happens when sodium transfers this electron? Think about what happens in terms of charge. How have they fulfilled their valence, or their octet rule? So when sodium, if you actually look at it, sodium has 1 valence electron. When it loses that 1 valence electron, it goes to a shell lower than it that's actually full. So sodium has filled its octet by losing an electron. Chlorine, on the other hand, will gain an extra electron, and by gaining that extra electron, its outer shell will become full. So they've both fulfilled the octet rule. So sodium, when it lost an electron, remember, when you transfer electrons or lose an electron, you become positively charged. Chlorine, on the other hand, gained an electron, so it becomes negatively charged. And what do these two oppositely charged particles, or what do these oppositely charged atoms want to do? Well, they want to combine, and they'll do so, and create this compound, sodium chloride. And the compound, when it combines, it's the sum of the total charges. It's going to be 0. How about magnesium chloride? What happens here? See if you can figure this one out. Did you pause it and try to figure it out? I hope so. If not, let's go ahead and get going. So magnesium has 2 valence electrons, and chlorine has 7 valence electrons. Magnesium's going to want to transfer its electron, and chlorine's going to become full, but magnesium's not quite happy yet. It has this extra electron. So what it's going to do, hopefully you figured out, it's going to find another chlorine in order to give it its valence electron. So this is kind of cool because it lets us know exactly how many elements I need per compound. So I'm going to get a compound formula of magnesium chloride. It's MgCl, and I need 2 Cls. So I need 2 Cls to begin with in order to create this compound. And this is my ionic compound. So what are the charges of each of these particles here? Well, if you think about it, this chlorine gained an electron, so it becomes -1. This magnesium lost 2 electrons, so it becomes +2. Remember, electrons are negative charge, so if you lose them, you become more positive. This chlorine gained an electron, so it becomes a -1. So what's the total charge here? Well, the total charge of the compound is going to be 0 if you add all those together. So here's where we're going to see that. So +2, -1 times 2, we get a total compound charge of 0. That's why you never write charges in the formula over here. You only write numbers of particles. So you need to know the common charges. Just remember, atoms tend to transfer electrons, and so these guys will transfer 1 electron and become positively 1 charged. These guys will get rid of 2 electrons and become +2 charge. We're going to ignore the transition metals and go to group 13. These guys have 3 valence. They become +3. These guys have 4 valence. They can go either way. They can either go up 4 or down 4, so they're kind of both. These guys have 5, so it's easier to gain 3 electrons and become -3 charge. These guys have 6, so they want to gain 2. These guys have 7, they want to gain 1. So notice hydrogen is here and here. Hydrogen is kind of weird. It can go either way as well. Most of the time it wants to gain 1, so it becomes -1. Now the noble gases here, remember, they're not really reactive. They don't really combine or bond with anything. They have a 0 charge because their valence electron is full. So why do atoms transfer electrons, and what is the consequence when that happens? Well, it all deals with this. They want to transfer because they want a full valence. They want to follow that octet rule. Oh, excuse me, I kind of jumped ahead, excuse me. So why do atoms transfer electrons? They want to fulfill that octet rule. What's the consequence? They become charged, just as we saw. So you need to know how to write ionic compounds. So let's talk about how we write ionic compound formulas. Ionic compound formulas are really simple. You just need to make sure that when you write them, the entire compound follows that rule of zero charge. It's the easiest way to write those formulas down. So here's an example. What if I wanted to write a compound between magnesium and fluorine? Well, first I need to know their charge, and I can pull that pretty easily from the periodic table. Magnesium has a +2 charge. Remember, magnesium had 2 valence electrons. It gets rid of them, so it's a +2 charge. Fluorine, on the other hand, has 7 valence electrons, so it wants one more. When it gets one more, it becomes a -1 charge. Now, is this ratio going to cancel each other out? No, not really. What I really need here is I need another fluorine. I need 2 total fluorines in order to cancel out that magnesium. So my formula is going to be written MgF2. And this is a compound formula. So try this one yourself. Lithium plus nitrogen. Pause the video, see if you can figure it out. Did you try it? I sure hope so. Here's lithium with a +1 charge. Here's nitrogen. Now, nitrogen has a -3 charge. Now, you can kind of see here visually what's going on. I need 3 total lithiums to cancel out that nitrogen. Now, when those come together to form a bond, I get Li3N. This 3 represents that I have 3 lithiums and I have 1 nitrogen. And now I've followed the rule of zero charge and everything's canceled out. How about naming? We need to talk about naming ionic compounds. Well, naming is really easy. Just take the metal name first, then the non-metal name, and then just change the ending to "ide." So here we have MgF2, what we figured out before. It's just magnesium fluoride. Then we have Li3N, what we did previously. This is just lithium nitride. So just the metal name and the non-metal name, end it in "ide." Okay, let's talk about covalent compounds now. We're kind of switch gears and talk about a different type of compound. So first, just remember, why do atoms transfer electrons and what's a consequence? Well, they transfer electrons because they want to gain a full valence shell. And when that happens, they become charged. The left atoms usually are the ones that want to give away their electrons, and the right atoms are the ones who want to take away their electrons. So what I mean by that is the metals give, the non-metals take. Now here in this, what we're going to talk about covalent bonds, what happens when 2 non-metal atoms come together? They both don't want to give their electrons. Well, that's what a covalent compound is. A covalent compound is between 2 non-metal atoms who don't want to give their electrons. So what they do in order to do that, in order to fulfill that octet rule, they share their electrons. And that's the biggest difference between ionic and covalent. Covalents share their electrons. So because they share their electrons, they never become charged. They don't stick because of their opposite charge. They stick because they're both holding on to those electrons and sharing them. So let's give an example here. Here's carbon with 4 valence electrons and hydrogen with 1 valence electron. Try to remember how many each of them want. Well, carbon wants 8 total, so it needs 4 more. Hydrogen's kind of tricky. You need to remember that hydrogen only wants 2. Hydrogen and helium are from the first period. They only want 2 electrons to fill their valence. So this is what's going to happen. Hydrogen is going to come and share its electron with carbon, and carbon is going to share its electron with hydrogen, and it's actually going to do that with 4 hydrogens. When that happens, each individual hydrogen gets their 2. This kind of circle here, this Venn diagram, shows the ownership of electrons. This hydrogen is going to have 2, and it's going to be happy. This carbon, when it shares with 4 hydrogen, it's going to be happy as well because it gets 2, 4, 6, and 8. So these are bonding electrons, or the electrons shared between them. So this is my covalent molecule compound, CH4. Carbon's going to combine with 4 hydrogens, and they're going to share their electrons. So how do you name covalent compounds? Well, it's pretty easy. It's the same as ionic, only you need to add a prefix. So these prefix here, you need to know these, or at least know that they're on the back of your periodic table. They're what you use before each element to determine the name of the compound, and then they end in "ide." There's one exception to this rule, and that exception is you never get to use mono or 1 for the first compound. So let's try some examples. Here's CO2. That's carbon, just one of them, and it's the first one, so we don't use mono, just carbon, and then there's 2 oxygens, so that's carbon dioxide. How about this one? Carbon again, but this time it's monoxide. This one is dicarbon, because there's 2 carbons, and then pentoxide. This one is dinitrogen nonoxide. I kind of screwed up here. It's just nonoxide, not no nonoxide. Next, it's nitrogen dioxide. Remember, there's two oxygens and only one nitrogen, and it's not mononitrogen because it's the first one. Finally, it's nitrogen, and then I forgot to include the monoxide. So monoxide right there. And now we know we named them all correctly because we use those prefixes. So the last thing you need to know is what a diatomic molecule is. There are certain non-metal elements that don't like to exist alone in nature by themselves, and they usually create this arrangement. Whenever you hear them in like a formula, or if anybody ever talks about them, they're usually in that arrangement. There are 7 of them. Just remember that there are 7 diatomicules that make a 7 on the periodic table, starting at element 7. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen are all diatomic molecules, and they make this arrangement here. So H2N2O2F2CO2Br2 and I2. So if I ever ask you for oxygen, you're really getting O2 particles because oxygen never exists alone. If I had a balloon full of helium gas, it would be a balloon full of H2. That's kind of different than hydrogen, or hydrogen gas. Hydrogen gas would be H2. Helium gas might just be a bunch of helium particles, just He1 floating around. Well, that's it, guys. That's the end of the notes and the end of the unit. Hopefully you remember all those things. Again, you need to know ionic and covalent compounds, their differences. How do you know which elements, or how do you know which compounds are ionic and covalent? How do you know which elements transfer electrons, which ones keep their electrons and share their electrons? Review all that stuff and you'll do really well on the test. You also need to know how to name each and their differences in naming. But good luck.